Today we're going to talk about reference angles and special right triangles. A reference angle is the distance from the x-axis. So for example, if I said find the reference angle, and I said letter A and I said 120 degrees. If I was to draw it in standard position, so again, starting here, 120 would be in this quadrant. Now our reference angle is if I was to draw a line straight down, what is that angle with the x-axis? So our reference angle would be 60 degrees. Let's say I said find it for 325 degrees. So again, I start by thinking, where is 325? Well, that's right here. And what is this distance? So from 325 all the way around to 360, so that's 35 degrees. What if I just said 80 degrees? Well, 80 degrees is right here. How far from the x-axis? Well, that's just 80 degrees. Now, a couple things. We can go negative degrees too. So if I said negative 142 degrees, well, where is negative 142? This would be negative 90. So this is negative 180. So here's negative 142. Well, how far is that to 180? Well, that would be 38 degrees. Our reference angle is always positive. And our last one, we're going to slide one more in here. Sometimes you might go more than once around the circle. For example, what if I said 700 degrees? Well, what is that the same as? 700 minus 360. Let's see. So 340 degrees. So that's the same place as 340, which falls right here. So 340 to 360, that reference angle is 20 degrees. And the second thing we're going to talk about today is special right triangles. So if we start with an equilateral triangle, right? Our angles are 60. So and our side lengths are all the same. Now if I was to cut that into half, that's where we come up with our 30, 60, 90 triangles. So do you guys agree that this is now 30, 60, this side length is n, this side length would be half of n. So if I wanted to find this other side in terms of n, do you agree I could set up n squared equals 1/2 n squared plus b squared? So n squared equals 1/4 n squared plus b squared. So we have 3/4 n squared equals b squared. And now if I square root that, I'd have the square root of 3 over 2 n equals this side length. So this is the square root of 3 over 2 n. Now, and those are our special right triangle values. Now, a 45, 45, 90 triangle. You guys might be like, well, that's just an isosceles triangle. So what do you know about a 45, 45 triangle? Well, two sides are the same. So what would that last side be? N squared plus n squared equals c squared. So 2n squared equals c squared. So the square root of 2, and I'll put that n in front, is c. Now, we're really going to be worried about the unit circle values. So what happens if our hypotenuse is 1? Well, that's pretty easy. On a 30, 60, 90 triangle, if our hypotenuse is 1, the side opposite 30 is half times our hypotenuse, so that's just half. And the side opposite 60 is the square root of 3 over 2 times our hypotenuse of 1. Now, if we look at this one here, so if that's 1, n equals 1 over the square root of 2. So our side lengths would be the square root of 2 over 2. So you might be like, Miss Husing, well, what does that mean? That means if I gave you any triangle, right? If I gave you any triangle and I said that this is 30 degrees and your hypotenuse is 1, you know those other side lengths. Opposite 30 is half. Opposite 60 is root 3 over 2. And the same thing, if I gave you a 45, 45, 90 triangle, and I told you that this is 1, your other side lengths, you automatically know, are root 2 over 2.